Hi guys, let's talk about how to do all of the mean value theorem problems. That's questions 1 through 7 in Achieve section 4.3. Now, remember, the mean value theorem is stipulating that the derivative or the instantaneous rate of change has to equal the average rate of change for some x value that we call c that's in between where the average rate of change begins and ends. So if I have this first function here that they give me, f of x is equal to x to the negative fifth power, which I know is the same thing as 1 over x to the fifth, what it's saying is that the slope of this function, or the average rate of change from 1 to 3, is going to have the exact same value as the derivative of this function for some value of x between 1 and 3. That has to be the case, or else the mean value theorem isn't true. Okay, so that's what we're doing in this section, is we're verifying it. So the first thing I do in this section is I'll go ahead and have to find the average rate of change for all of these problems. Well, the average rate of change from 1 to 3 is just the function evaluated at 3 minus the function evaluated at 1 over 3 minus 1. That's just y2 minus y1 over x2 minus x1. Well, f of 3, well, that's just going to be 1 over 3 to the fifth. That's 1 over 243. F of 1 is just 1 over 1 to the fifth, or just 1. Now, I have my numerator 1 over 243 minus 1 over 2. I just went ahead and did that on the calculator, so let me show you here. If I want to do a fraction on there, I go alpha y equals fraction, and I'll even do the fraction in the numerator and say I have 1 over 243. And then from that, we're subtracting 1, and we're dividing that by 2. And it's going to give me a decimal if I want to change that decimal, and I certainly do. I would rather change that to a fraction. I get the negative 121 over 243, which you see matches the answer I got earlier. Now, we say that is the average rate of change of this function from 1 to 3. Now, our goal is to find out what the instantaneous, or what value of x has that exact same instantaneous rate of change. So when I'm looking at that here, I can go in and say, well, all right, and I'll try to get this clear. Let's see, there we go. I can go in and say, well, the derivative of this function is going to be negative 5 times x to the negative 6th power, which gives me negative 5 over x to the 6th. Now, this is my derivative. The mean value theorem says that your derivative, the instantaneous rate of change, must equal that average rate of change for some value of x in between 1 and 3. That's my goal. So I set the derivative equal to my average rate of change. All I did was I cross multiplied here. Negative 5 times 243 was negative 1215. Negative 21 times x to the 6th formed my other side. So x to the 6th is going to end up being a positive 1215 over 121, and Achieve just wanted a decimal, so I just went to my calculator, typed that in, rounded to 3 decimal places, and got the 1.469. 1.469. That answer is fine. Now, for the second problem here, extremely similar. This one, it's giving me a trigonometric function, y is equal to the square root of 3 cosine x minus the sine of x, and it's wanting us to verify the mean value theorem for this function between 0 and 2 pi. Okay, so I have my function here, and I'm trying to think about what the average rate of change between 0 and 2 pi is. So you'll see I just plugged 2 pi into my function, minus when I plugged a 0 into my function. So this is f of 2 pi minus f of 0 over 2 pi minus 0. Now, this, it doesn't really plug in too nicely. We know that the sine of 2 pi and the sine of 0, they're both 0. And whether you take the cosine of 2 pi or the cosine of 0, you get a 1. So I get the square root of 3 times 1 minus the square root of 3 times 1. Your whole numerator ends up just being 0 because it's the square root of 3 minus the square root of 3. Divide 0 by any number, you get a 0. So I just need to show that my derivative is equal to 0 for some value of x between 0 and 2 pi. That's what the goal of the mean value theorem. So I take my derivative. I know derivative of the cosine is negative sine, so I got negative root of 3 sine x. And then derivative of sine is cosine, so I have minus cosine of x is equal to 0. Now I set that equal to 0 by going ahead and adding the root of 3 sine x to both sides, and I got the negative cosine of x is equal to the root of 3 sine x. And then I said, well, if I divide by the cosine on each side, sine over cosine is tangent. And then I also divided by the root of 3 on each side. So I got negative 1 over the root of 3 is equal to the tangent of x. Here I've shown both places on the unit circle where that is true. When is the tangent of x negative 1 over the root of 3? Well, it's when the ratio of sine to cosine is negative 1 over the root of 3. That's true at 11 pi over 6. The sine over the cosine would be negative 1 over the root of 3. It's also true at 5 pi over 6 because the ratio of sine over cosine would be 1 over the negative root of 3, same fraction. So I can say my two values that satisfy this criteria, please notice my derivative would equal to 0 at either of these points. And all that mean value theorem said is that there had to be at least one value of x where the derivative was the same thing as the average rate of change. Well, we not only found one, we found two. Now, Achieve is wanting us to put both of them in here in this case, and it says give your answer as a comma-separated list. Okay, so I'll move this down just to help me put this in here, and I'll say, all right, what I need for the first one is 5 pi over 6, so I'll say 5, and then the pi button is right here. We're just dividing that by 6. And then comma, my second one is 11 pi over 6, so 11 pi divided by 6. We should have our two answers. These should be correct. We'll check it and move on. Okay, so now the next one here, it actually goes to an easier problem for this one. You'll see it's the exact same mean value theorem. It's giving me a cubic function, y equals x cubed from negative 5 to 6. Supposed to verify the mean value theorem. So we say mean value theorem just simply states that the derivative must equal the average rate of change for some x value between negative 5 and 6. So I find the average rate of change, f of 6 minus f of negative 5 over 6 minus a negative 5. Clearly my denominator is a positive 11. My numerator is just going to be 6 cubed minus a negative 5 cubed. But a negative 5 cubed is a negative 125. If you're subtracting a negative 125, you're adding 125. So I have 6 cubed, 216, plus 125 in that numerator. When I did that and divided by 11, you'll see I got my 31. I said 216 plus 125. The numerator would have been 341, but then we're dividing that by 11 to get our answer of 31. So then you can say, okay, that's the average rate of change. Now I need to show that the derivative, which is very easy, just 3x squared, the derivative must equal that average rate of change for some x value in between negative 5 and 6. So if 3x squared is equal to 31, then x squared is equal to 31 over 3, which then means x is equal to the square root of 31 over 3, and it could be the positive or negative root. Either one is going to be satisfy the relationship, because notice the square root of 31 over 3, that's going to give me like 3.215. So it'd be a positive negative 3.215. Both of those numbers are within our region. Now in this problem, it wanted exact forms. You know it, the way you know it wanted exact forms is it didn't say anything about round to 3 decimal places. So it'll want the negative square root of 31 over 3 and the positive square root of 31 over 3. I'll go in here and try to enter that in. I'll say, okay, I have the negative square root of 31 over 3, and then I'll do comma, and the positive square root of 31 over 3. That should be absolutely fine. We'll check that answer and move on. The next mean value theorem problem, a lot of people struggle with this one, so let me make sure I take my time and try to explain it as well as possible. It's asking us to verify the conclusion of the mean value theorem for the exponential equation 7e to the negative 8x plus 9 on the interval 0 to 2. Okay, so whenever I'm doing this on this interval, first thing I need to do is find the average rate of change. So the average rate of change is just going to be f of 2 minus f of 0 over 2 minus 0. But if you evaluate your function at 2, you're just going to get 7e to the negative 16 plus 9. That's where I got this at. If you evaluate your function at 0, you're just going to say, well, that's just going to be e to the 0 power. You're going to have 7e to the 0 plus 9. Clearly, your 9's go ahead and cancel out. And then you need to remember, any number raised to the 0 power is 1. So you have 7e to the negative 16 minus 7 times 1. That's just 7e to the negative 16 minus 7. Again, I had my denominator of 2. So now I needed to take the derivative. Well, the derivative was going to be the derivative of any exponential is that exponential function times the derivative of its exponent. I said negative 8 times 7 is negative 56. I keep the exponential function e to the negative x. Of course, derivative of the constant, 0. I set my first derivative equal to what my average rate of change was here. And what I thought about in this case is I knew I could factor a 7 out in the numerator here, and it would leave me e to the negative 16 minus 1. So what I was thinking of is I had a factor of 7, but I'm going to be dividing by a negative 56. So the way I did that in my head, and I did just do it in my head, I didn't use my calculator, but to show you the logic on the calculator, I knew I would be dividing by a negative 56. Well, 56 divided by 7 means, well, I only need to divide by a negative 8. So when I went from this step to this step, I just said, well, I'm going to cancel out the 7, and then I'm going to divide by negative 8. That's the same thing as dividing by negative 56. So I get the 2 becomes a negative 16 when I divide by the negative 56. I cancel out the 7, and I have a nice simpler expression. In order to solve for x, though, you need to get rid of the exponential base, which means you need to take the natural log of both sides. So I get negative 8x is the natural log of the quotient e to the negative 16 minus 1 over a negative 16. Now, at this point, I didn't particularly like that negative 16 in the denominator inside that natural log, so I got rid of it. I just said, let's multiply by a negative 1 over a negative 1 inside that natural log. That's going to make your numerator 1 minus e to the negative 16th over a positive 16 inside that natural log. In order to solve for x, I had to divide by negative 8. Now, the way that you would evaluate that on your calculator is you could say, well, okay, we need to enter in this expression, and I could see some people messing up on it, so let me do it step by step here. We know the whole problem's a fraction, so I'll go ahead and do alpha y equals fraction. And then you're going to have the natural log of a fraction in your numerator, and my numerator of that fraction was 1 minus the exponential function second natural log. So 1 minus e to the negative 16. I'll arrow down to the denominator of that log and put my 16 and then say that closed out my logarithm. My denominator was just a negative 8. So I'm positive this should give me the correct answer. And we get the 0.347, which matches what I got when I tried this earlier. Let's see if Achieve agrees with that. 0.347, check answer, correct. Up next, number 5. And number 5, it goes back to an easy problem. I'm not quite sure why it goes from a really cool, fun problem back to an easy problem here. Number 5, just a basic quadratic that we're trying to verify the mean value theorem on. So we get 51x squared on the interval 0 to 17. I find the average rate of change from 0 to 17 by saying, well, what's the function evaluated at 17 minus the function evaluated at 0 divided by the change in x, 17 minus 0. Well, f of 17 is just 51 times 17 squared. Now, I just used my calculator for that, of course. I just said 51 times 17 squared. I got that numerator of 14,739. Now, of course, then I needed to divide by the denominator of 17, to get my average rate of change of 867 units there. Now, in order to find out the value x equals c that satisfies the mean value theorem, I took the derivative, which was 102x. I set that equal to the average rate of change. And so clearly you can just get x is equal to 867 over 102. And that would easily be within your range from 0 to 17. And it says use fractions when needed, so shouldn't be any problem here. I'll just say 867 divided by 102. Perfecto. We'll check that. And it's saying next question. Number 6 goes back to an exponential function, which is kind of cool here. So for this one, my exponential function is 8e to the x, and I'm trying to find or verify the mean value theorem on the interval 0 to 9. So I'll say I first need to find the average rate of change between 0 and 9. F of 9 minus f of 0 over 9 minus 0. F of 9, that's just going to be 8e to the 9th. F of 0, 8e to the 0, of course. Of course, my denominator 9 minus 0 is just 9. Now, in that numerator, I went ahead and evaluated it by factoring out an 8. And when I factored out the 8, it left me e to the 9th minus e to the 0. And of course, we know e to the 0 is 1. So now I have my simplified expression for the average rate of change. I want to set my derivative equal to that. Well, the derivative of the function is just the function. You just say derivative of any exponential function is that exponential function. We take that, set it equal to my average rate of change, and I can say, well, okay, in order to do that, all I'd have to do is divide by 8 on each side. When I divide by 8 on each side, I'll get e to the x is equal to this expression without that factor of 8 in the numerator. And then in order to solve for x, you just take the natural log of both sides, and we should get x is the natural log of e to the 9th minus 1 over 9. Now, unlike number 4, it's not wanting a decimal approximation here, so I need to enter it in just as I see it here. I'll say, okay, we have the natural log, and then I'll say of the group e raised to the 9th minus 1. We'll close out that group, and then we're dividing that group, and I'll show this a little bit better. We're dividing that group by 9. Oops. Well, that was unfortunate. Let me go back in and try that again. We have the natural log of the group e raised to the 9th power, and then minus 1. Close that. Mercy. I will get it right, guys. I promise. Minus 1. Close that numerator. We're dividing that. And I should have just used the division sign within achieve. It had been easier. This should be correct, though. We have the natural log of e to the 9th minus 1 over 9. Check answer, and it's saying correct. Last one here goes to a quadratic function. Sorry, not a quadratic, a radical function. 4 on the root of x, and we're interested in the interval between 0 and 7. So when I thought about that, I said, well, okay, my f of x is 4 root of x. I need to find the average rate of change between 0 and 7. So it's just f of 7, which is 4 on the root of 7 minus f of 0, 4 on the root of 0, over 7 minus 0. Your numerator, any number times 0 is 0, so you're just going to have 4 root of 7 in the numerator, divided by that 7 in the denominator. Now, we need to take our derivative, and I thought of this as 4x to the 1/2. So the 1/2 came down, multiplied the 4, and gave me a 2. And then you decrease the power by 1 to get x to the negative 1/2. That's the same thing as 2 over the root of x. Then I can say, well, now that derivative must equal the average rate of change. I cross multiplied to get 14 is equal to 4 times the root of 7x. From that, in order to solve, I needed to square both sides. 14 squared is 196. 4 squared, 16. The root squared just gave me 7x. Now, 16 times 7x was 112x. You solve for x by dividing by 112. And I just went to my calculator and said, what's the reduced fraction for 196 over 112? reduced down to 7 over 4, reduced down by a factor of 28, in fact. Now, in order to see this, I would just type in C is 7 over 4 here, and I will see that that answer is correct. Now, after that, it goes into different types of problems asking for critical points. I'll go ahead and cover that in another video. Hopefully this gives you a very good explanation and coverage of what I expect you'd be able to do with the mean value theorem. Let me know if you have any questions.